If you've ever been to see an optometrist, it's possible that these images might be familiar to you. They're called Ishihara plates. The purpose of one of these Ishihara plates is to gauge a patient's ability to distinguish certain colors, primarily red and green. So as of the posting of this video, it is September 6th, which is International Colorblindness Awareness Day, and it marks the birthday of a scientist by the name of John Dalton. Dalton was the father of modern atomic theory, but he was also color vision deficient and was one of the first scientists to thoroughly document his own condition. Now, it's important to point out that true color blindness, or achromatopsia, which is the inability to see any colors at all, is actually pretty rare. When we talk about color blindness in our day-to-day lives, typically we're referring to something called color vision deficiency, right? And this just means that the patient is unable to distinguish certain colors from others. So oftentimes they'll have trouble distinguishing their reds from their greens, and in rarer cases they'll have trouble distinguishing their blues from their yellows. So what exactly is going on within the eye that causes color vision deficiency? Well, in order to discuss color vision, we have to talk about the wave property of light. So light, or visible light, is actually a range of wavelengths on what we call the electromagnetic spectrum, right? So what happens is you have a wave of light that travels into the eye and it hits back here at the retina, right? Well, the retina contains a specialized group of cells that we call photoreceptors. Photo being light, receptor meaning receiver. So light, receiver, right? And here in the very center of your retina is a region called the macula. And the macula contains a high concentration of specialized photoreceptors called cones. We call them cones. Now, each cone contains one of three different photopigments. This little photopigment receives long wavelengths. This little photopigment receives medium wavelengths, and this one receives short wavelengths. And as you can see, they all correspond to wavelengths on the electromagnetic spectrum. So what happens is millions of these cells receiving different wavelengths of light and processing them in your brain create the sum effect of your color vision. But what happens when one of these photopigments is either absent from the cell or isn't functioning correctly? Suddenly you're not receiving these wavelengths of light, and the effect is that you're not going to be able to distinguish them from one another, and this is the mechanism behind being color vision deficient. So what causes this to happen? Well, color vision deficiency is linked to a number of different minor causes, and these include certain diseases, medications, chronic alcoholism, chemical exposure, and aging. But the primary cause of color vision deficiency is your genetics. So you've probably heard it said before that men tend to be more colorblind than women. And this is actually true. According to the National Eye Institute, color vision deficiency occurs in roughly 8% of males and about 0.5% of females of Northern European descent. Why does this happen? Well, color vision is what we call an X-linked trait, right? Which means that it exists on the X chromosome. Now, if you'll recall your knowledge of genetics, males have an X chromosome and a Y chromosome. whereas females have 2 X chromosomes. So what happens when we have an X chromosome that is actually carrying the trait for color vision deficiency? Well, in this female here, she has an X chromosome that has the trait for color vision deficiency, but there's a counterpart on her other X chromosome that is dominant to that color vision deficiency trait. So this woman here is not going to show any color blindness. However, she is now a carrier of color vision deficiency. So if she were to happen to have a son, it's possible that he will receive that X chromosome that carries the color vision deficiency trait. And being a male, he does not have a counterpart X chromosome that contains the dominant trait that would keep him from having color vision deficiency, and such, he's going to have some issues. So presently, there is not a cure for color vision deficiency. However, scientists are currently studying gene therapy as a possible avenue for curing the disease in the future, because if we can alter the genetic makeup of the patient, their photoreceptors may start creating the photopigment correctly, and they will be able to see color. For the time being, all we're really able to do is prescribe certain tinted lenses or glasses that will assist the patient in distinguishing certain colors. However, it will never grant them the full color vision offered by fully functioning photoreceptors. So that's everything we're going to cover in the video today. Now, if you're interested in this topic, I compiled most of this information from these 2 sources, the American Optometric Association and the National Eye Institute. And both of these sites have very good pages that go into a lot more detail than even I did in this video. Now, if you think that you may be having some of these symptoms, if you're suffering from color vision deficiency and you want to get evaluated, you can always feel free to contact us to schedule an appointment, and we can actually do those diagnostics here in our office. So if you liked this video, do stay tuned. I'm going to have more coming on the way, so like, subscribe, share, help us out if you can, and I'll be back in a couple weeks with more content. Thank you so much for watching.